So we already know that exponential functions and logarithmic functions are inverses of each other. And so what we're asked here is, what is the graphical relationship between an exponential function and a logarithm? So really what we're asking here is, what's the relationship graphically between two inverse functions? And this may be something you recall from high school or earlier math course, but in fact, any inverse functions are going to be reflections of each other across the line y equals x. So if you take a, so let's pick different colors here. If you pick, sorry, hold on, sorry about that. If you take an exponential function, say 2 to the x, that's not my best picture, but work with me. So if it was base 2 and you compared that to a logarithm base 2, oh, that is really not very good. Sorry about that. This is going to be the inverse function. So they're going to be reflections. Imagine that those actually look like mirror images of each other across the line y equals x. So here's an example that's drawn by Desmos, so it'll be much clearer than mine. We have two functions. This one, excuse me, one of them is a log base 3. That's the red function. And the green is log base 1/3. So notice that both logarithms, well, actually, let's talk about this up here. We've already talked about exponentials have a horizontal asymptote on the x-axis, and so logarithms, if you reflect that over the line y equals x, they're going to have a vertical asymptote, the y-axis, right? So notice these two logarithmic functions have that vertical asymptote showing up, which is not surprising. And this red one looks a lot like the one I tried to draw above. But what's going on with this green one? Why, when the base is 1/3, why is it decreasing? Right? And so to understand that, we really just have to think about what the function 1/3 to the x looks like, right? Remember, 1/3 to the x is exponential decay. So it's going to have this sort of shape, right? So if this is y equals 1/3 to the x, that's a 3. So what would that look like if we reflected it over the line y equals x? Well, in fact, rather than me drawing it, it's going to look like this green curve. Right? So if I take this graph 1/3 of the x and I reflect it over line y equals x, I'm going to get a decreasing logarithmic curve, right? And so that's what it's going to look like. But notice both of them do have a vertical axis, a vertical asymptote on the y-axis. Okay, so the reason we really care about logarithms for this Math 118 course is really to solve interest problems, to be able to solve for that exponent. So let's think about the kinds of problems that we now can solve now that we know about logarithms. So we take that rich uncle example that I've been using a lot in this course. If I wanted to know on what day is this $1 million offer actually equal to this doubling your money every day offer, right? So if I really wanted to solve, like, when is this function equal to $1 million, I now want to algebraically solve this equation here for x. So algebraically, how do I get x by itself? Well, unlike PEMDAS, when we're solving, we start with adding and subtracting, then we sort of work our way back up in reverse order of operations, right? So think about that in a simple case. If I was solving 3x plus 5 equals 8, I first start with any addition subtraction, then I would do the dividing to solve for x, right? So we work in the opposite direction, inverse operations in the reverse order of operations. So here, if I want to get x by itself, I notice I have multiplication and I have exponents. I want to do the multiplication or division first. So I'm going to divide both sides by 3. So I'll be left with 2 to the x is equal to 333,333.3 repeating. And now I want to solve for, how do I get rid of this exponent? How do I undo exponential base 2? Well, that's the new skill we've just learned. We're going to take log base 2 of both sides of the equation. So I'm going to take log base 2 of 2 to the x and log base 2 of 333,333.3 repeating. Now over on the left, I just get x. That is because, by definition, log base 2 is the function that undoes exponential base 2. And over here, I now just have to evaluate a logarithm base 2, and I can use any online calculator to do that. So if you do that, you're going to get an answer of 18.346 approximately days. And so on the 18th day of the month, I'll be at $1 million. So somewhere between 18 and 19, I will have earned $1 million using this double your money offer. Okay. So that's an example of solving these interest problems for the exponent.